Hello everyone, welcome back to my channel. I'm Sanjana, and in this video let us see the probability mass function and distribution. In this video let us see probability mass function, example problem of problem mass, applications of problem mass, probability distribution, example problem of probability distribution, and applications of probability distribution. Probability mass function. What is probability mass function? Probability mass is defined as function which gives the probability that a discrete random variable is exactly equal to same value. It is also known as discrete probability density function. The probability mass function is often the primary means of defining a discrete probability distribution, and such functions exist for either scalar or multivariate random variables whose domain is discrete. If, for example, value xi of a discrete random variable x, we assign a real number p of xi such that p of xi is greater than or equals to 0. Summation of p of xi is equals to 1. Then the function of p of xi is called a probability function. If the probability that x takes the values xi is pi, then p of x is equals to xi is equals to pi or p of xi. The set of values of xi comma p of xi is called a discrete finite. Probability distribution of the discrete random variable x, the function p of x called the probability density function or the probability mass function. Mean is calculated by the following formula: sigma xi p of x. Variation is calculated by the formula sigma xi square into p of x minus u square. Now let us see the problem based on probability mass function. A coin is tossed twice. A random variable x represents the number of heads turning up. Find the discrete probability distribution for x. Also determine its mean and variance. You can see the table and as well as the discrete probability distribution for x that determines mean and variance. For doing means, we use u is equals to sigma xi into p of x, and whereas for variance we take sigma xi square into p of x. According to that, we'll calculate and find the mean and variance as shown there. And now let us see the applications of probability mass function. Applications are as follows: statistics and data analysis. PMFs are used extensively in statistics to analyze and model discrete data. They help in understanding the likelihood of different outcomes in scenarios such as survey responses, game outcomes, or product defect rates. Quality control. In manufacturing processes, PMFs can model the probability distribution of defective products or faults in a production line, aiding in quality control strategies. Now, let us see probability distribution. A probability distribution is a mathematical function that describes the likelihood of different outcomes or events in a particular scenario. It provides a way to quantify uncertainty by assigning probabilities to various possible outcomes of a random experiment or a random variable. Discrete probability distribution. This type of discrete distribution is associated with discrete random variables which have a countable number of possible outcomes. Examples include the binomial distribution, Poisson distribution, and geometric distribution. Whereas continuous probability distribution. Continuous probability distribution applied to continuous random variables that can take any value within a specified range. Example, the normal distribution, exponential distribution, and uniform distribution. Now let us see example for probability distribution. Show that the following distribution represents a discrete probability distribution. Find the mean and variance. Now from this table, we have to calculate the mean and variance for showing the uh, discrete probability distribution. As we know that mean is nothing but u is equals to sigma xi into p of x to calculate the mean, and for calculating variance, sigma xi square into p of x minus u square. Using these formulas, we can calculate the mean and variance for the following table. Now let us see the applications of probability distribution. Engineering and physics. In engineering, probability distribution are used to model the reliability of system, failure rates, and lifetime of components. In physics, distributions describe phenomena such as particle decay, energy levels, and quantum states. Telecommunications and networking. Probability distribution are used to model data traffic, packet arrival times, and signal strength variations in communication networks. They aid in designing and optimizing network protocols and resource allocations. Machine learning and data science. Probability distributions are formed machine learning for modeling data and uncertainty. They are used in algorithms like Gaussian mixture models, Midden Markov models, and interface methods. Thank you. Please like, share, and subscribe.